All right, this topic is solving for a missing bound. And what I mean by that is if I have an integral like this from 0 to b of x cubed is equal to 56, I'm saying, hey, the area under my curve of x cubed is 56, or area of 56. What would this b have to be? So that's what this question is going to be asking. But I want to just take a second really quickly to talk about this phrase right here, the fundamental theorem of calculus. What is that? Well, it's fairly underwhelming. It's actually something we've already learned. It's basically saying that the integral from a to b of f of x dx is equal to f of b minus f of a, where, of course, if we take the derivative of uppercase f, we get lowercase f. So in other words, f prime of x is equal to f of x. And if that's even confusing, I just want you to think of it as the fundamental theorem of calculus is just the way that we calculate a definite integral. That's it. Basically taking the integral and then plugging in the top bound and then subtracting it when we plug in the lower bound. All right, so now let's go ahead and attack this problem now that I've kind of talked about what these problems are going to look like and what this fundamental theorem of calculus is. So the question asks, the area in the first quadrant under f of x equals 3 over x on the interval from 1 to b is equal to 6. Find the value of b to the nearest thousandth using the fundamental theorem of calculus. So do you guys remember what the function 1 over x looks like? This is one of those ones that I had you memorize in pre-calc. So just as a reminder, it looks like the following. It's got a horizontal and a vertical asymptote. It looks like this, and it looks like this. So what would 3 over x look like? Well, what do you think? Looks pretty much exactly the same. It's just been translated a little bit. So not much difference. I'm just going to keep that picture. So I'm being asked the area in the first quadrant. So I have to go ahead and erase this black one right here because we don't care about that. And it's saying on the interval from 1 to b, it's saying that the area under the curve, that area right there, is equal to 6. So in other words, this black area has an area of 6. And I know that my function is 3 over x. I know that this is 1. I know that the area is 6. But what I don't know is what b is. Is that from 1 to 5? Is that from 1 to 3? What is that? So let's go ahead and try to figure this out. So we know that the integral from 1 to b of 3 over x is equal to 6. So here are my bounds from 1 to b. Here's my function, 3 over x, given to me here, and I'm told that that area under the curve is 6. So what I'm going to do is I'm just going to pull that 3 out in front. And this is kind of a common thing that you can do if you ever want, just like that. So now I'm going to integrate. And I know that the integral of 1 over x is a ln x. So an ln absolute value of x. And of course, I'm going to put my 3 back in there. And I'm saying that that is going to be evaluated from b to 1, and that's going to be equal to 6. So you see what I did there? I put the 3 back here. I've got the integral of 1 over x is this. And now that I've taken the integral, I've got to evaluate it from here, my upper bound, to 1, my lower bound. All right, so I'm going to plug in b. So I'm going to get 3 ln absolute value of b minus 3 ln 1 is equal to 6. What is natural log of 1? Well, think about that. That's log base e. Natural log is log base e of 1 equals question mark. That's saying e to the question mark equals 1. Well, that's going to be 0. So this whole thing is 3 times 0, so that's going to disappear. So I'm just going to be left with a 3 ln absolute value of b is equal to 6. Now I'm going to divide by 3 on both sides. Okay, and that's going to give me natural log of absolute value of b equals 2. Now, how do I get rid of natural log? Don't you dare say divide by natural log. Nope, you are going to take e to the power of both sides. We learned that in pre-calc. And here, e to the ln is going to disappear, and you're just left with simply b equals e squared. And that's it, you're done. So that's, in order to get an area under the curve of 6, you'd have to have your b, that upper bound, be e squared. So we just found that this was an e squared. Okay? All right. Let's try another one, eh? All right, the area under the first quadrant, that's cool. We're eliminating to the first quadrant again of that function on that interval. So I've got my interval from 0 to b. That's coming from right here. My function is 2.5 x to the 2/3 dx, and that's going to be equal to 48. All right, let's go ahead and integrate this. So we know that the answer here is going to be 2.5 x to the, we'll add 3 over 3 to this, so that's going to give you 5/3. But then I'm multiplying it by 3/5. And I'm going to evaluate that from 0 to b, and that should be equal to 48. Okay, let's just go ahead and tidy this up a little bit. We've got 3/5 times 2.5. I'm just going to multiply that in my calculator, and I get 1.5. So this is going to be a 1.5 x to the 5/3 from 0 to b is equal to 48. All right, let's go ahead and plug b in here. So this is going to be 1.5 b to the 5/3. And then I'm going to plug in 0, and I actually get minus 0, and that's going to be equal to 48. Well, I clearly don't need the minus 0. But what I can do is I can divide by 1.5 on both sides. So that's going to cancel, and I'm going to be left with b to the 5/3 is equal to 48 divided by 1.5 gives me 32. Now, how do we get rid of b to the 5/3? Well, we can just raise it to the power of 3/5. And what I do to one side, I have to do to the other side. Now 5 times 3 is 15, and 3 times 5 is 15, so this becomes 15 over 15 when I multiply these fractions. So that becomes b to the power of 1, or just b, which is exactly what I wanted. When I multiply these, they cancel. I'm just left with b. And then, folks, just put this in your calculator. 32 raised to the power of 3 divided by 5. And I get a lovely answer of 8. So what does that mean? And you can actually check these answers. Like what I would do on your calculator right now is check that the integral from 0 to 8 of 2.5 x to the 2/3, plug that in your calculator using Math 9, and you should confirm that you get a 48. And you could do the same thing with the last problem too. You could plug e squared in for this and see if you do in fact get your 6, and I know that you will. All right, last problem, and if you want you can pause this video, try it on your own, and see if you get the same answer as me. So the area in the first quadrant under this curve from 0 to b is equal to 12, so I'm just going to get that down. So that's going to be from 0 to b of cube root of x dx is equal to 12, which I'm going to go ahead and rewrite as from 0 to b, x to the 1/3 dx is equal to 12. So I'm going to go ahead and integrate that by adding 3 over 3. So that's going to give me x to the 4/3. Then I'll put a 3/4 here. From 0 to b is equal to 12. So now plugging in b, I'm going to get 3b to the 4/3 over 4. And then I'm going to subtract, plugging in 0 now. Well, that's nice. That just gives you -0. So I don't even have to write that. That's going to be equal to 12. So I'm going to go ahead and multiply by 4 on both sides. Actually, you know what? Yeah, let's multiply by, instead of doing this in 2 steps, let's just multiply by 4/3. That'll be kind of nice. Why do I do that? Well, the 4 cancels with the 4, the 3 cancels with the 3, and I'm left with b to the 4/3 is equal to 12 times 4 divided by 3, which is 16. All right, last step is just like our last problem where I'm going to raise this to the power of 3/4, raise this to the power of 3/4. This cancels, and I'm left with a b equals 16 raised to the power of 3/4, which I get to be 8. That's my answer. And again, you can go ahead and check. Literally go back to this one right here, change this to an 8, plug this in your calculator, and make sure you get a 12. All right, that's it, folks. I hope you enjoyed this. These problems don't look much different than this. Thanks for watching.